Hello everyone, good evening. Welcome back to Gate Wallah English YouTube channel. I hope everyone is doing great. So till last class we have covered infiltration. We have completed the infiltration topic thoroughly. I hope you have understood it completely. So let's have a quick recap and after that we'll start. So good evening Manish and Sushil. Good evening. I hope you all are doing great. So yes. So in yesterday's class, what we discussed in yesterday's class, see, we solved this question and we discussed the concept that when your infiltration value is more and intensity of rainfall, infiltration capacity is more than the intensity of rainfall, then in that case, sir, I will take the area of rectangle and no integration will take place. But when infiltration curve is less than intensity of rainfall, in that case, I will do integration to find the infiltration value. Okay, this we have already discussed in the last class. After this, we solved some questions. We discussed what phi index was. I told you phi index was basically average rainfall above which the rainfall volume is equal to runoff volume and below which the rainfall volume is equal to infiltration. Okay, whatever rainfall we have will be equal to infiltration below this average phi value, and above it will be runoff. Okay, and we discussed that phi index basically is denoted for all the intensities of rainfall, or you can say it is only denoted when you have excess rainfall. Okay, so basically in that time in which excess rainfall is there, we will consider phi index for that time only. Okay, that's why I divided by excess time. I hope you all remember what excess time is in which excess rainfall occurs. Okay, so excess rainfall, the extra rainfall basically denotes runoff volume. Okay, this you have to remember, it's very important. And how to find phi index? Okay, I have told you the algorithm and also showed you some great examples with the help of which phi index, I hope, was very clear to you. So this was one of the examples. This was basically showing you the application part, how to what is the application of phi index. The application of phi index is basically to find the runoff volume. This I have already told you. I hope you remember it. And then we solved one great question with the help of which we have understood the process of finding phi index. Okay, basically first what you have to do, you have to take different trials. We will stop the trial when all the I are greater than phi. Okay, so we have to stop when all the i's are greater than 5. But if some intensity of rainfall are coming less than or equal to 5, then I will remove them. This was the ultimate process which you have to remember. Okay, I hope this was very clear to you. And why we adjusted it? We adjusted this phi value so that we adjusted this phi value until the excess rainfall, this white shaded area, should be equal to runoff. We adjusted it up to that value. Okay, I hope you have understood the entire concept. And at last we have solved some questions and we have discussed what W index was. Okay, and W index was more refined and it gives you value which is less than phi index, because in this we consider the initial losses. Okay, so this was it which we have discussed in the last class. Okay, so definitely dear Sushil, don't worry. See, obviously you haven't covered all the subjects. Yes or no? Tell me. Kindly comment. You haven't covered all the subjects. And since you haven't covered all the subjects, I am guessing it. You must have covered only the important subjects. So yes or no? So next time, you should prepare yourself in such a way that you cover all the subjects first. Okay, you revise everything properly. Give proper test. Okay. Tell me, Sushil, if you have given your best attempt. This one. Okay. Tell me. Obviously, since you have not given your best attempt and since you have not covered all the subjects, you have only covered major subjects, and that too not in depth. Yes or no? So obviously you will get less marks. And this time paper was also very difficult. This time paper was also tough. Okay, as compared to every time. So this time paper was tough. Yes or no? So that's why your marks are less. So no need to get demotivated or lose hope. Simply keep studying. You will get good marks next time. Okay, so just don't worry, just keep following the lectures and solve. And you can also join one batch. Okay, I've told you that today, see, on from 20th of March one batch is going to start, that you can join from March 2023, 20th March. Shresht batch is going to start. Okay, Shresh 2.0 batch is going to start from 7 p.m. to 10 p.m. Daily it will run. Okay, this you can attend. Daily classes will be there from Monday to Friday. So from Monday to Friday 7 to 10 p.m. you can join these batches if you want to cover your subject in 2 years. This is a 2-year program, and if you want to improve your rank only, then you can join Vijeta batch. I have already told you this thing. then you can join Vijeta batch, which will run in morning from 9 a.m. to 1:30 p.m. Okay, in which only question practice will be there, so that your rank is getting improved. So you can join any of the batches. Shresh batch has been launched in weekday also, in weekend also, so you, depending on that, you can join it. Okay. Okay, so this is it. Now today we are going to discuss about runoff. Okay, what runoff actually is. See, we have discussed precipitation, we have discussed all the losses or abstraction from precipitation. So obviously now the turn is to discuss runoff. Okay, I already told you. So in today's class, the topics which we are going to discuss is like what is runoff, how we compute runoff volume. Okay, what exactly runoff is, that we'll discuss. How it takes place, what are the characteristics, that we have to discuss. What are the types of streams? We will discuss different kind of streams that exist or that are developed when your runoff takes place. Okay, so we'll discuss different kind of streams, and at last we'll discuss what is flow duration and flow mass curve and what are their applications. So this is the ultimate aim of our class. So after completing these topics, we'll end it. Okay, so first we'll discuss what is runoff. First we'll discuss what is runoff exactly. Okay, now so you need to understand, I have already told you one thing. Let us imagine this is a let us imagine this is your ground. Let us imagine this is your ground. Okay, and let us say this is your river. Okay, let us say this is your river. So let us assume this is your groundwater. Let us assume this is my groundwater. Okay, sir, this is the groundwater. So and this is your, let us say this is your impermeable layer below which no water will go. Okay, this is your confining layer basically. I will show you what runoff exactly is and what are the different components. If you'll pay full attention to this class, you will know the concept of runoff. Okay, so let us say this is the confining layer. Okay, so let us say this is the confining layer below which no water will go, and this is indicating your groundwater table. Okay, this is your groundwater table. So let us use blue ink here. Okay, obviously blue denotes the color of water. So this is your groundwater. Let me write here. This is your groundwater. Okay, see, I will tell you later, don't worry. See, this is your groundwater, and let us say this is your base flow. Okay, the flow which is taking place at the bottom, is your groundwater. So this is your groundwater. Okay, and let us imagine we have some trees here. Okay, let us say we have some trees, some crops or some vegetation over your surface, and let us assume precipitation has taken place here. Okay, let us assume precipitation has taken place. Okay, sir, no problem. We have already discussed the precipitation chapter and your losses chapter. Okay, so let us assume precipitation has taken place here on the landmass. Okay, this is your precipitation thing. This is your precipitation. Okay, sir. So after precipitation, what will happen? See, we are interested in finding the runoff now. See, when precipitation happens, listen very carefully. When precipitation happens, what will happen after precipitation, sir? I will see that some portion will be filled in these depressions. Okay, some water will be filled in these depressions, which will slowly and steadily infiltrate. Okay, sir. Some water will get, you all can understand, some water will go in the form of evapotranspiration. Already discussed this thing. Transpiration, evaporation, all these things will be there, but we are not interested in that part. But you need to understand one thing. Let us suppose we have a huge catchment area. Okay, let us suppose we have a huge catchment area. Understood, sir? In this catchment area, in the central part is the lowest line in which all the water ultimately drains off. This we have already discussed. This is the main central stream of your catchment area. Sir, after rainfall, let us say rainfall has taken place. So what will happen after certain period of time? You will see that water will start forming a small network of streams. And ultimately all the water will come down and join your main central stream. This will be the case after some time. Okay, water will come from here, it will join this one, water will join this. Yes or no? Like this you will see that water will ultimately start forming small streams, and this stream network formation will be there, and you will see all the water will ultimately drain into the main river. Okay, so this is your thing. So ultimately what is happening here? Ultimately this is what? This is runoff. This is what? This is runoff only. Okay, sir, this is runoff only. So water ultimately is going into the valley line. Okay, and this is what? This is the outlet. This is the outlet of your catchment area. Understood, sir. Now let us imagine, listen very carefully. See, this is very important, because if you are unable to understand this, hydrograph chapter will be hampered. Hydrograph is the most important topic, so please listen very carefully. Okay, so let us say this is your outlet. This is the you can say this is the outlet from where all the water will leave the catchment area. This is the entire catchment area. Whatever water falls after after your water has fallen, what will happen? This stream formation will be there, and through these streams, through this network of streams, all the water will ultimately drain into the main stream, and from main stream water will reach your outlet and leave the catchment, So what I will see after rainfall in this main river, I will see that discharge goes up. Okay, let me draw with different thing. What I will observe, that stream was having certain flow. This is your discharge versus time graph. This is your discharge versus time graph. Okay, so stream was having certain flow, discharge was almost constant, or let us say it was increasing or decreasing, but not up to great extent. Understood, sir? But you know what will happen after rainfall? After rainfall, you will see that this graph will jump sharply. Okay, see, this is the discharge versus time graph at this section. Okay, we are standing here. Let us assume we are standing here and we are in a boat on this river. What will happen? We are measuring discharge versus time at that curve. So what will happen after rainfall? You will see that water will start reaching there. As soon as more and more water will reach your outlet, you will see that this graph will start increasing and will reach a peak value, and then it will decrease again. See, rainfall will end. You all know rainfall will end after some time. So when rainfall will end after some time, you will see that all the water will reach the outlet. All the water will reach the outlet, and you will see that graph will go up to a peak value. Then again your discharge will decrease, and again then it will become almost constant. This is the general case which you will observe with any kind of outlet which is generally present at the end of your catchment. Okay, so this is it, this simple thing. So this is discharge versus time graph, which is known as hydrograph. Okay, this is discharge versus time graph, which is known as hydrograph. So basically sir, you are saying that discharge versus time graph will be changed after rainfall. Okay, after rainfall, sir, I will witness that my stream, my river, okay, it will collect all the water from the entire catchment area, and the peak will and this discharge will shoot up to the peak, and then it will decrease again. Yes or no? Is this clear? Kindly write yes. Understood, sir. Now we are interested in runoff. Okay, sir, you are teaching me runoff chapter. So how runoff will take place? I want to try understand how runoff will take place here. So runoff will basically take place in 3 parts. Okay, can you tell me how this runoff will take place? If water has fallen on this entire catchment area, okay, if water has fallen on this entire catchment area, what things we will see here? Can you just guess? See, the very first thing is overland flow. Wait a second. Let me drink water then. Okay. So listen very carefully. So what will happen? Some water will directly flow over the surface. Some water will directly flow over the surface, known as overland flow. Okay, sir. Overland flow. What is the meaning of overland flow? Overland flow is the flow which is taking place over the land. Over the land. That's why I am calling it as overland flow or surface flow. Okay? Or you can say surface runoff. Or I can also call it as surface runoff. Understood, sir? What next? What next component we have? Now, some water, for sure, so some water will go into the ground. Yes or no? Obviously, rainfall has taken place. Some water will be flowing onto the land, but some water will penetrate inside also. Definitely. Some water, after penetrating inside, they will start moving. they will start moving like this. So this is what, this is interflow. This is interflow because this water is not flowing over the land or over the surface, but it is flowing beneath the ground. Yes or no? This is subsurface flow, also known as subsurface flow. Okay, also known as subsurface flow or interflow. Sir, you are saying that some water will flow over the land, some water will flow beneath the land. Okay, some water will flow with the ground itself. So this is your subsurface flow. Understood, sir? Now you need to understand, after a long time, after hours, let us say after 10 hours, 20 hours, 48 hours, 72 hours, 3 days, 4 days, 5 days, sir, this water will slowly and steadily percolate and join your groundwater table. Okay, so some water will percolate deep down, and then it will start flowing, and then it will start flowing towards your river, and then it will start flowing towards your river. This is what? This is your groundwater flow. This is your groundwater flow, also known as base flow. This I have already written here. Okay, also known as base flow. This is known as base flow. Okay, now I am asking you one question. Can you tell me, see, let us assume this is first, this is second, this is third. Almost all are ultimately reaching into the river. All the water will reach into the, see, why river? Because sir, you need to understand that river is the you can say, sir, lowest line. Yes or no? In this entire catchment area, the river is at the lowest level, and all the water which has fallen on the higher level. So obviously water will seek lower level. Yes or no? Water will try to reach lower level. This is true. So obviously all the water will ultimately, no matter what, it can flow over the land, it can flow beneath the surface, or it can join groundwater table and then it can flow. But ultimately what has to happen? Ultimately all the water has to join the lowest line, the valley line. This is the lowest line, the valley line. Yes or no? See, these areas are higher, and all the water drains off into the lowest areas. This is the lowest line. Okay. So can you tell me this? Let us say this is 1. Let us say this is 2. Let us say this is 3. Can you guess which will take most time, or you can say the highest time to reach your river? Is it overland flow, is it subsurface flow, or is it base flow? Which will take the most amount of time? Which will take the maximum time? Can you guess? 1, 2, 3. Which will take the maximum amount of time to reach your river? Just tell me. Let me see if you are able to understand this. If we consider them on the basis of time, which will take maximum time? Tell me, everyone kindly comment. Which will take maximum time? Tell me. Which will take maximum time? On the basis of time, if we consider time, if we arrange your overland flow, interflow and base flow, the maximum time will be taken by base flow, because the water has to travel first. It has to travel kilometers, or not kilometers. It has to travel certain meters, 100 meters, 200 meters down the ground to reach groundwater, and then it has to flow from here. So on the basis of time taken, precipitation, to reach river, we have, if we order them, okay, then base flow will take the maximum time. At second, in general, you will see that interflow or subsurface flow will take less time. Why? Because water does not have to go deep down. Okay, water will infiltrate, and as soon as it has infiltrated, it will start flowing. Okay, this can be quick or this can be little slow also, but interflow will take time less than base flow. Okay, and the least amount of time will be taken by, obviously, the water which is present on the surface. The water which is quickly reaching your river, the water that will reach quickly to the river will be the overland flow. That means overland flow is the quickest one. Overland flow is the quickest one. See, one more is even quicker than this one. Okay, one more flow is there. See, you need to understand, you need to appreciate this fact that some water will directly fall onto this river, sir. When precipitation takes place, some water will directly fall onto the river. This is your channel precipitation, yes or no? This is the river precipitation. Some water will directly join the channel, directly fall on it. So obviously it will take the least amount of time, yes or no? That will take the least amount of time. So if I am talking of channel precipitation, obviously since it has fallen directly onto a river, in order to reach the outlet, see, this will take the least amount of time to reach the outlet. See, whatever water has fallen on the river itself, that water will take the least amount of time to reach your outlet. This is general trend. Okay, keeping all the other factors constant, I can ensure that this is a trend. Okay, so basically my runoff can be this runoff thing can be decomposed or distinguished or classified into three components. Yes or no? Is this thing clear? Is this thing perfectly clear? Understood? Now, you need to understand one thing. That after rainfall, some water will reach quickly, some water will take time. The water which is taking time is known as base flow. Listen very carefully. I have told you that you must have seen, in no matter what, in whatever city you are living, no matter it doesn't matter, but you must have seen that in your river, more or less you will see water flows throughout the year, or water flows you can say in most of the months. Yes or no? So from where that water is coming? The question arises, from where that water is coming. Okay, see, some are glacier oriented. Somewhat in Himalayan rivers you must have observed that all the water basically comes from melting of glaciers. But listen very carefully, some rivers are not glacier oriented. Okay, so from where that water is coming? So you should answer that those rivers, listen very carefully, those rivers which are not getting their water from glacier as a source, those rivers are getting water throughout the season in form of base flow. Okay, base flow is the groundwater. See, this groundwater is there only because of rainfall. Yes or no? Tell me. This groundwater comes only after rainfall, and this groundwater will ultimately flow into the river. Why this water flows there? Because river is the lowest, you can say, lowest level of your entire catchment area. It is the lowest level, so water will flow there. So you need to understand, I told you that some water is always there in the river. This was the water which is already there in the river, but after rain you will see that we have some quick effects, and some water must have reached quickly, and because that quick runoff, you will see that graph will go up. Okay, it will come down again, and again you will have slow effects. Again you will see that some water will reach slowly and steadily, some water will reach slowly and steadily, hours after, days after your rainfall. That is none other than base flow. So base flow is you can say base flow is having a long term contribution. Everyone kindly comment. Base term is having long term contribution. Water flows throughout this river, you can say throughout this year, with the help of this groundwater. Okay, so you are seeing that even after rainfall has stopped, even after 1 month, even after 15 days, even after 2 months, you will see that water which has fallen 1 month ago is flowing into the, is going into the ground, joining the groundwater table, and slowly and steadily reaching the river. That's why the river is having certain amount of flow maintained throughout the year. Okay, obviously in some rivers you will see that they get dry when hot seasons or dry season is there, but you will see that after rainfall these base flow are maintained up to many months, and because of that you will see that your rivers have certain amount of water throughout the year. Okay, is this thing clear? So base flow is responsible for basically your natural flow of rivers. Base flow is responsible for basically natural flow of rivers. Okay, and after rainfall, whatever water we see quickly, which is reaching into the river quickly, that is because of this overland flow and interflow. Okay, so I hope this entire thing is clear to you. But basically if we consider runoff can be classified into two parts basically. Okay, runoff can be classified basically into two parts. First is overland flow. Also referred to as surface runoff. Okay, this you have to remember. And secondly, some water flows and joins your river which is flowing just below the ground. Okay, see, you need to understand, some water must be flowing from here, some water must be flowing from here, So whatever water is flowing from here will reach quickly, and whatever water is will be flowing from here will reach later. Why? Because more the depth, water needs to percolate down to this depth, so obviously it will take time. This horizontal distance is constant, but vertical distance in this case is more. If the water has to percolate, or if the water has to percolate, you can say more, then obviously time taken will be more. Okay, so lower the water has to percolate, higher will the time for that water to reach your river. Okay, so I will say that overland flow, surface runoff will be the fastest one. And secondly, we have interflow. Interflow, the water which does not reach your groundwater but starts flowing and joins your river water. Okay, so interflow is subsurface. Why subsurface? Because it is beneath the ground. Now, if I want to talk of entire component, I have a table which is very, very important, with the help of which you will understand everything. Okay, so let us draw that table. So you should understand we will draw certain boxes here. So this is your precipitation. Then we have this is next box. This is then we have this box. Okay, four. Basically your entire precipitation will be divided into four components. Okay, tell me, sir, those four components. Sir, the entire precipitation is divided into four components. Okay, the very first one is channel. See, all the water which reaches your ground. See, first from that water losses will take place. Okay, losses I will write here. This is your abstractions. Okay, sir, what sort of losses? What sorts of abstraction? Obviously, sir, we have discussed abstractions like evaporation, transpiration, okay, interception, like that. Initial storages. Okay, we have discussed all these things. Interception is there, depression storage is there. All these are abstractions. So whatever water is remained, okay, some water will fall directly on the channel. Some water will directly fall on the channel, known as channel precipitation. Channel precipitation. Okay, out of that precipitation, some part will directly fall on the channel. Some will be joining your river through surface. This is your overland flow, and some will infiltrate. Okay, some water will go inside the earth. So this you need to remember. Understood, sir? This is simple. So channel precipitation will be there, overland flow will be there. Okay, then we have abstractions from precipitation, and at last we have infiltration. Okay, so these many components are there. Now you need to understand from this infiltration thing, two components arise. This is the first one. Okay, and this is the second one. So from infiltration we have basically two components. The very first one is, see, whatever water goes inside, you need to understand, whatever water goes inside, some water will be part of interflow, and some water will be part of whatever water will percolate deep down, that will be part of base flow. Yes or no? So I will write here that some water which is going into the ground will become, whatever water will go into the ground will become interflow, or subsurface runoff. Okay, see, this is a part of runoff which is taking at a shallow depth. Interflow is taking place at a shallow depth. But if that water is going deep down, if that water which is going deep down is known as deep percolation, that will join your groundwater table. Okay, that will join the groundwater table. Now, from this interflow, some water will be quick. From this interflow, you need to understand some water will be quick and some water will be slow. Some water will be quick and some water will be slow. This you need to understand from here. Okay, sir. So tell me what we have to understand from here. Wait a second. Okay, so from this interflow, we have two connections. Okay, sir. So out of this interflow which is taking place beneath the surface or below the surface, some will be quick, some will be very quick. That's why I will call them as rapid interflow. Some will be very quick. That's why I will call it as rapid interflow. Some will be slow. Some will be slow. That's why I will call it as delayed interflow. It will take time. It will take time. Okay, sir. No problem. Then we have deep percolation. See, whatever water we go deep inside will join ultimately your groundwater only. Will ultimately join groundwater only. Yes or no? Will ultimately join groundwater only. Now, whatever water will be flowing over the land, whatever water will be flowing over the land, that is surface runoff. That is surface runoff. Now, you need to understand one thing. See, this channel precipitation, or let me join this thing here. Not like this. Wait a second. See all these parts. See, whatever water is falling on the channel, whatever is the surface runoff, whatever is the rapid interflow, all these parts will reach quickly to the river. All these parts will reach quickly to the river. That's why I will call it as direct runoff. Direct runoff means the one which will take very less time and it will reach quickly to your river. It will reach quickly to your river after the rainfall. After rainfall will take place, immediately within 1 or 2 hours, you will see that all the water will reach your river and ultimately your outlet. Okay. But you need to understand some water will take time. Some water will take time. That is your groundwater and delayed interflow. Okay. They will take time. So delayed interflow, the interflow which will take time, the groundwater that will also obviously take time. Okay. That is your base flow. That is your base flow. Base flow is what? If someone asks you like what base flow is, you will say it is none other than delayed flow. Okay. It will take time. This is delayed flow. It will take time. That is quick flow. That is delayed flow. If you will sum it up, okay. If you will sum it up, you will get this is what. If you will sum it up, you will get total runoff. You will get total runoff at the outlet. So this is the entire summary of your chapter runoff. This is when you will combine both of them. Okay, you will get the total runoff at the outlet. So ultimately, sir, what we have understood from here? That some water will reach quickly and some water will take time. Okay, sir, you are saying, see, in this diagram, sir, you have told me that some water, whatever water is flowing above the land, obviously that will reach quickly. So that is quick runoff. Okay. In this interflow, some part will be quick, some part which is going deeper will be slow. So whatever is reaching quickly, that is direct runoff, and the slower part here, and the water which is going to the ground, which is none other than base flow, that will take time to reach your river. So obviously that is delayed flow. And obviously some water which will be falling directly on your channel, that is obviously quick. So sir, overall we can say after rainfall, what we can say is that after rainfall, we need to understand this thing. Sir, after rainfall, let me write here. After rainfall starts, after rainfall starts, some water, some water, some portion of rainfall, let me write, some portion of, some portion of rainfall drains quickly, some portion of rainfall, some portion of rainfall drains quickly, some portion of rainfall drains quickly, some portion of rainfall drains quickly, but some portion takes, some portion may even take, but some portion may even take months. Some portion even may even take months. Based on that, based on that, based on that, we can classify this entire runoff thing into two parts. The first one is direct runoff, which is the quick portion, the water which reaches quickly, and the next one is your base flow. Base flow is the water reaching your river when your rainfall has stopped long time ago. Okay, so this is your, this is showing you quicker response just immediately after rainfall, and this is showing you delayed response. This will take place even after months rainfall has taken place. Okay, so this is the flow which is generally there in the rivers. You see that after rainfall has stopped, even then some of the water is there in the river, yes or no? So that is none other than base flow. I hope. Okay, you are saying Q. What is the Q? Where I have to write Q? So this is your Q versus time. I hope runoff is clear. I hope now runoff is clear. So this is the ultimate table. So water which is falling over the channel, water which is coming from the surface over the land, and some part of interflow are quick enough. These three are quick enough. But some part of the interflow and some part which is going deep down into the groundwater are generally slow. So base flow and quick direct runoff. These are two components. I hope these are clear to you. Okay. Now we'll move ahead. I hope this runoff table is clear to you. Tell me, sir. Tell me that this thing is very clear to you. Everyone kindly comment once if this thing is clear. Yes or no, tell me. So if this thing is clear, then we'll move ahead with runoff characteristics of a stream. After this, we have to study how streams behave. Okay, after rainfall, how streams behave, that we have to understand. Perfect. Now we'll discuss the types of streams. So basically we have three types of streams which we have to discuss. Okay, Abhijit, great. Yes, now we'll discuss different kinds of streams. Okay, so basically, see, runoff thing, you need to understand after precipitation. Let me write this thing here. See, after precipitation, what happens? After precipitation, what happens basically? Okay, see, you need to understand after precipitation, you need to understand that water forms a small network of streams. Okay, water forms a small, water forms or water flows through, water flows through small streams, water flows through small streams which, okay, which joins, water flows through small streams through a network of streams. Basically water flows through through small streams after formation of, after formation of network, after formation of network of streams, after formation of network streams, and then joins and then joins the main, and then joins the main stream, and then joins the main stream. So ultimately you need to understand what is the cycle here. See, the cycle is, sir, first thing is precipitation. So precipitation will take place. Okay, sir. Now after this, sir, all the abstractions, all the losses will take place. Okay, sir. All the abstractions and all the losses will take place. Abstractions from precipitation, we have discussed all this thing in great detail. Now after this, uh, abstractions, sir, what I will see after all the losses have taken place, I will see stream flow. I will see that small streams have formed, small streams have formed in my entire channel, and these networks of stream will this formation of a small networks of stream will be there, and you will see that water will travel through this. Okay, so first runoff will be there, and then I will see that stream will carry huge amount of water and will ultimately drain that water into the main central stream. So first runoff will be there, see, in order to reach here, water has to flow from here. Okay, so whatever will flow from here and reach your stream. Okay, so first what will happen? First runoff will happen. First what will happen after the abstractions, I will see runoff will happen, and after your runoff, ultimately your water reaches your stream, and then that water becomes a stream flow, So this is the pattern. Precipitation, losses, after losses runoff will take place, be it overland, be it interflow. All that water will reach your streams, small networks of stream, and ultimately that will be a stream flow. Okay, that will be your stream flow. So I hope this is clear. Rahul is saying, sir, is it a deep complete course? Yes, dear. Yes. Obviously, Rahul, I will not leave you in a single concept here. Okay, so I hope this is clear. Okay, now we'll discuss different kind of stream. So ultimately, sir, you are saying water will become a part of stream flow. Yes or no? So we have to have understanding how many types of stream can be formed. Okay, how many types of stream can be formed. So based on this, streams can be classified into three types. Okay, the very first one is, so let me write here, streams can be classified as, listen very carefully, sir, streams can be classified as the first part, perennial stream. Okay, what is the meaning of perennial stream? Sir, these are the streams which will have water throughout the year. These are those kind of streams which will have water throughout the year. Okay, so let me write here, perennial means throughout the year, evergreen. Okay, perennial means which will flow throughout the year. So I will write here that these streams generally flows throughout the year. These streams flows throughout the year. Yes or no? These streams flows throughout the year. Second part is that 100% dependable flow. 100% dependable flow will have some finite value. What is the meaning of this? I will tell you, just don't worry. So this is very simple point, but before understanding this point, we have to understand, let us say this is your perennial stream. Let us assume this is your perennial stream. See, in perennial stream, you need to understand that in perennial stream, the level of water will be more in monsoon season. Yes or no? Obviously, sir, in monsoon season, the level of water is more. Yes. So I will write here monsoon. And let me also draw one hydrograph for this one. Okay, I will also draw a hydrograph for your perennial stream. Okay, I will make sure that this hydrograph is having water throughout the year. Okay, so this will be the hydrograph here. Okay, sir, you were saying this is your perennial stream. Sir, in perennial stream, the water in monsoon season is more, but when dry season, okay, when summer season will be there, then obviously this water level will come down. But still in dry season this water level will come down, but still, sir, I will have some water. Yes or no? I will have some water. Yes, sir, we have some water. That's why I am calling this water to be perennial. Why? Because this kind of stream or river is flowing throughout the year. Because even in dry season, when your river can dry, then also some water is there. That's why it is perennial. Yes or no? Yes, dear, you can watch from there. Okay, SK, you can watch from there, no issues. After this, I will not take irrigation, so you can watch from there. Okay, you can cover from there. Okay, so we have this perennial stream. See, obviously, you will see that you all know that in 1 year we have 12 months. Okay, you all know that in 1 year we have 12 months. Okay, let us say this is the starting month, first, second, third, fourth. Okay, like this, let us say we have 12 months. Okay, it's from 0 to 12. Now you need to understand, if I am going to plot this graph, I will see this is discharge versus time curve. Okay, this is discharge versus time graph. Discharge versus time graph is known as hydrograph. Okay, now in this perennial streams are obviously in dry season discharge will be less, in monsoon season discharge will be more. So this graph will be somewhat like this. Okay, so discharge will vary. It will be more or less same when we have dry season, but when we have monsoon season, obviously this graph will peak. Okay, this graph will peak like this. Okay, so like this you will see that after monsoon season will end, you will see that this graph will come down like this. Okay, so this is the time, this is the month like June, July, August, September. These are those kind of months, because in this we have rainfall. Okay, so I hope this thing is clear. So this is the hydrograph of perennial stream. This is the cross section in which I am indicating different kind of seasons. Okay, I am indicating the level of water with respect to different kind of seasons. I hope this is clear from here. And this is your definition of perennial stream. Now, one last statement we have to understand is 100% dependable flow will have some finite value. What is the meaning of this? You need to understand. See, in monsoons, our discharge is most. Let us assume that in monsoon we have 100 meter cube per second discharge. Okay, sir. In monsoon we have 100 meter cube per second discharge, but that discharge will not remain there throughout the year. Why? Because this discharge will not remain throughout the year. So I will say that this discharge will occur there with a probability of only 25%. Okay, in entire year we will find such kind of discharge only 25% of the times. So 25% dependable value, the discharge on which I can rely only 25% of the times, that is 100 meter cube per second. Understood, sir? Now let us lower the discharge. Let us say the lowest discharge in this river, which will remain throughout the year, no matter what happens, no matter how much you can say how much dry this season is. Okay, but still you will have 10 meter cube per second water always in this river. So the probability of this discharge to occur in this river, let us say is 1, or let us say 100%. So obviously you can depend on this discharge 100% of the times, because every time you will come in this river, every time when you will see this river, you will have this percentage of this much of discharge for sure. So they are saying, since perennial stream has certain amount of discharge throughout the year, so obviously it will give you certain amount of discharge, some finite value of discharge. Okay, some finite value of discharge such as 10 meter cube per second 100% of the times throughout the year. Okay, you can depend on this discharge 100% times, because this will be the lowest flow value which will occur throughout the year. At least this much of water will be there throughout the year. So 100% dependable flow, the discharge which will occur 100% of the times in that stream will have some value, at least 10 meter cube per second discharge, like this. I hope this is clear. Okay, at least it will have some kind of discharge, some finite value of discharge. But this is not the case with other kind of streams, sir. This is not the case with other kind of streams. Okay, let me give you an example. Now I will take example of intermittent stream. Okay, this is not the case with other kind of streams, sir. Perennial stream is very clear to me. Now we'll understand second kind of stream, which is known as intermittent stream. Okay, second kind of stream is intermittent stream. Okay, sir. Now what is intermittent stream? Listen very carefully. intermittent stream is a one which remains dry in which remains, you can say, empty or no water is there in dry season. But when monsoon season comes, you will see water is there. Okay, let me show you the cross section first. Let me show you the cross section. Let us say this is your cross section. Okay, so in monsoon season, what I will witness, in monsoon season, I will say water is there. I will see that in monsoon season, sir, water is there. But in dry season, water will go below the surface, so no water will you will see there. Okay, in dry season, the water will dry up so much that the level of water will be even below your river bed. Okay, even below your river bed, so no water you will see. Okay, if I will show you this with the help of a graph. Okay, this is the hydrograph which I am going to draw here. So in this hydrograph you will see, wait a second. So in this hydrograph I will show you how much discharge you will get. Okay, in this also we have time from 0 to 12 like this. Okay, like this we have some months. Okay, here we have time. So you will see that we will have you will not have discharge will be there for some time, then no discharge, immediately rainfall is there. When rainfall is there, sir, I will see immediately the graph is going up. Okay, when rainfall is there, immediately my graph will go up like this. Okay, like this I will see some peaks. Yes or no? So I am seeing that my graph is giving certain peaks when monsoon season is there. Because of monsoons, rainfall is there. When rainfall is there, we have certain amount of water in the river. But when dry season is there, when no rainfall is there, then I will see that for some months, some 4 to 5 months, I have no discharge in that stream. That's why, since it is not having discharge throughout the year, I am calling it as intermittent stream. Why intermittent? Because flow is intermittent. Flow is discontinuous. Sometimes flow is there, sometimes flow is not there, sometimes again flow is there. That's why intermittent. I hope you have understood why the name intermittent is there. Yes or no? I hope you have understood why the name intermittent is there. Okay, so I am trying to make you understand that these streams remains dry. These stream remains dry for summer season or dry season. Okay, these streams remain dry for dry season. And it has limited contribution from groundwater. Okay, what is the meaning? What is the meaning of limited contribution from groundwater? Which means that this groundwater will be available sometimes and sometimes it will not be available. Okay, so groundwater flow, base flow will be available sometimes and sometimes it will not be available. That means it is limited. Okay, so if you want to write here, can you tell me that 100% dependable flow will have some finite value? No. You need to understand that in this river there is no discharge. There is not even a single value of discharge which is existing here for 100% of the times. We can see that in this river sometimes it is also going dry. So obviously no magnitude of discharge is there which is having, okay, which is having 100% probability to occur there. Okay, so we need to understand that in this river 100% dependable flow will not have some finite value. 100% dependable flow will have zero value because 0 meter cube per second discharge will occur there for 100% of the times. Okay, so obviously 100% dependable value will not have some finite value in this case, but it will be in this case because in this perennial stream you will have certain discharge throughout the year. But here, since you don't have certain amount of discharge, so obviously dependable flow will be will give you zero value. Okay, I hope this thing is clear. Tell me, now we'll discuss the third kind of stream. Now we have to discuss the third type of stream. Okay, sir. So this is perennial, this is intermittent. Now we'll discuss ephemeral stream. The third one, the last one. Now we'll discuss ephemeral stream. The third one. We have already discussed perennial stream, intermittent stream. Now, how ephemeral stream is different? See, in ephemeral stream, you need to understand there is no groundwater contribution whatsoever. Let us say this is your ephemeral stream. In this one, you will see that when monsoon season is there, then also water table is below the ground. When monsoon season is there, then also water table is below the ground. When summer season is there, dry season is there, then also your water table is below the ground. Then you will see, then you will say, sir, then how water will be present there in this river? Okay, when in monsoon season and dry season, both the seasons, river water is you can say the water table is not going up. So how this will receive water? From where this stream will receive water? So for that you have to understand this will have water only in rainy season. After rainfall, you all know that this will receive certain amount of water only in rainfall season, otherwise it will not, it will have no water. Okay, so let me write here, the meaning of ephemeral stream. So ephemeral stream is which does not have, ephemeral stream is which does not have, any base flow contribution, which does not have any, base flow contribution. Okay, groundwater contribution in this ephemeral stream is zero. But from where it will receive water? Sir, it will receive water, it is also known as flashy river or flashy stream. Why? Because after rainfall you will see the water is there, but as soon as rain stops, after some time this water will also stop. Okay, so after rainfall you will see that some water is there, and immediately after rainfall you will see that water will stop. So I will say that it receives water soon after rainfall, soon after rainfall, it receives water soon after rainfall. Okay, now last point in ephemeral, and intermittent, stream, in ephemeral and intermittent streams, 100% dependable flow is 0. Why? Because the discharge which will always be there, present, which will always be present there in the river is 0. You will observe throughout the season. Okay, 0 discharge you will observe throughout the season, be it ephemeral stream or be it intermittent stream. But here you will have at least 10 meter cube per second discharge or 20 meter cube per second discharge occurring throughout the year. Okay, so is this thing clear? Tell me if all these three kinds of stream are clear to you. Perennial, intermittent, ephemeral. Tell me. After all these kind of streams are clear to you, we'll move ahead with another topic. Okay, wait a second. Today results are out. Okay, so See, content is sufficient here. Sushil, you are asking one doubt here. Content is obviously sufficient, but you need to understand, if you want to get proper hand holding, or if you want to get if you want to also solve DBPs, okay, extra material, gate OPD and all these things, if you want, you can join it. Okay, obviously it is affordable, but if you don't want, you can study from YouTube only. Okay, see, in that you have systematic batch. Okay, in that you have systematic batch will start on fixed date and end on fixed date, so obviously that gives you more consistency, so you can join if you want to. Okay, yes, if it will be useful, definitely, if you are preparing or studying subjects for the first time, 100% it will be beneficial for you all. Okay, so obviously these kind of batches are for you all only, and at such affordable prices. Okay, these are at such affordable prices, so obviously you will be able to uh, complete your course within time, and you will be benefited properly. Okay, now we'll understand. Now we have clearly understood the definitions of perennial, intermittent and ephemeral. Now we'll try to understand what natural flow is. Okay, now I will write the definition of natural flow here. See, these days you will see that natural flow is not there. Okay, you will see that these days no natural flow is there, because see, whatever stream flow is there, if that stream flow is uninterrupted by the man-made works, okay, these days you will see, you must understand that, let us assume we are living in a city. Okay, we are living in a city, and in city, tell me, let us say you are living in Lucknow. Let us take an example of Lucknow, and you all know that in Lucknow we have Gomti River. Okay, so in Lucknow we have Gomti River. So tell me, is the flow of Gomti affected by man-made works, or is it not affected, or is it unaffected by man-made works? So obviously, since it is a city, we are controlling it. We have made a barrage on Gomti River. Okay, we have made a barrage. All the sewage water is going into the Gomti River. So obviously that flow which is there in the Gomti River is affected by man-made works. Since it is affected by man-made works, I will call this flow as artificial flow. Yes or no? It is not perfectly natural flow. I hope this thing is clear. Okay, so but in old times, when natural flow when stream flow was not affected by man-made works, then it was natural flow. So what is natural flow? Natural flow means stream flow unaffected. I will say stream flow which is unaffected by stream flow unaffected by works of a man, such as reservoirs, etc., that is unaffected. Okay, that is unaffected by works of a man, such as reservoirs. Okay, we have not constructed any kind of reservoir on river, we have not constructed any weir or barrage. So then I will say that stream flow, then I will call that stream flow as natural or virgin flow. Then that stream flow is called as natural or virgin flow. Okay, so I hope this thing is very clear to you. So this is your theory of runoff characteristics of stream. Now we'll discuss how to determine the runoff volume. Is this thing clear? Simple, basic definition of natural flow. But one thing is missing here. Okay, I have not showed you the hydrograph of ephemeral stream. Okay, I haven't showed you the graph of ephemeral stream. So let me draw here. The graph of ephemeral stream. See, ephemeral stream will have water only after rainfall. Whenever rainfall is there, you will see water is there, but when rainfall is not there, you will see no water is there. Like this, it will be dry throughout the year. Okay, so if you want to draw the hydrograph, for your ephemeral stream, in that case I will see, again it will have certain amount of, again we will have certain 1 2 3 4, like this. We have so many months in your here, let us say 12 months. You need to understand, you will see the graph of this ephemeral stream like this. Okay, when a small kind of rainfall is there, you will see a small peak is there. Okay, water will shoot up and it will fade away quickly. Okay, water will be there, it will fade away quickly after your rainfall has stopped. So let us say rainfall is there, after rainfall some water will be there, and as soon rain will stop, you will see no water is there. Okay, like this. Again we will see that in months of June, like this, we have more rainfall. So like this you will have certain peaks. Okay, these are flashy rivers, these are flashy streams. Immediately water will there and it will you can say drop away immediately. Okay, like this you will have certain peaks, like this you will have certain peaks. So I hope this is very clear to you. Okay, so this is your graph, this is your hydrograph of your ephemeral stream. I hope this is clear. Perfect. Now we'll try to understand how to find the runoff volume. Now we'll discuss certain methods with the help of which we'll determine runoff volume. Okay, so we have discussed till now different kind of streams, what runoff is. Okay, what are its different components, what are its different components. We have understood all these things. Okay, now we'll discuss how to determine runoff volume. Okay, before understanding runoff volume, let us first write the definition of basin yield. What is the meaning of basin yield? What is the meaning of basin yield? Obviously, see, this is your, wait a second, so many slides I have taught you today. Yes, so this is your catchment area, this is your watershed, this is your basin. Okay, this is your water. See, throughout the year, let us say we want to find basin yield for 1 month. So what I will do, you need to understand, after in a 1 month time, all the water which is being yielded by this basin will be reaching this outlet. So what you can do here is simply compute the discharge, simply compute the total discharge which is coming out from outlet for entire 1 month. Okay, so for entire 1 month, in 1 month's time, simply compute how much discharge is coming out from here and find the total volume, and that total volume will be the basin yield. That total volume will be the basin yield for a 1 month, let us say April or May, like that. Okay, so basin yield means whatever amount of water is being yielded or is being liberated by this basin in 1 month, 2 months, 15 days, throughout the year, like that. So basin yield is what? If I want to find basin yield, what I have to do, let us say if I want to find basin yield from 0 to 6 month, then what I have to do, I have to integrate this hydrograph. I have to integrate this hydrograph from 0 to 6 months. If I want to find for 1 month, I have to integrate from 0 to 1 month. If I want to find from 6 month to 7 month, I will integrate this graph from 6 to 7. So basically we have to integrate. Okay, we have to integrate QDT. We have to integrate QDT. Is this thing clear? That will be the yield which will be given by your basin. So basin yields water. Okay, basin yields water. Obviously basin will yield some water after rainfall, that is for sure. So basin yield is the quantity of water. Okay, I hope this is clear. After rainfall, in certain duration of time, water will be yielded or will be coming out of your outlet of catchment or basin. That total quantity of water is known as basin yield. So quantity of water, so the total quantity of water available, from a stream, the total quantity of water available from a stream over a specified duration of time, over a specified duration of time, over a specified duration of time. Okay, over a specified duration of time is known as basin yield, and the formula will be integrate QDT, find the total area from time T1 to time T2. Yes or no? You have to find the time, you have to find the yield from time T1 to T2. This will give you the yield. Okay, simply this is nothing but your area under hydrograph. This is simply your area. This is simply your area under hydrograph from time T1 to T2. This is simply your area under hydrograph. Yes or no? Tell me. From time T1 to T2. Okay. So I hope this basin yield is also clear to you. Now, how I will determine runoff volume. Okay. I am writing the definition here. Determination of runoff. How I will find runoff? Sir, how I will find runoff? Now we have to understand this thing. Okay, how I will find runoff. So we are interested in finding the runoff now. Okay, what are the ways, what are the methods with the help of which I will be able to estimate or compute runoff volume? Okay, this slide is focusing on runoff volume now. So the very first method is, you need to understand in earlier times, many scholars have worked out different areas. Okay, they have collected huge amount of data and they have given some empirical equations. Okay, using those data, they have found some empirical equations. Many scientists have worked upon it. Okay, I will name some of the few important works which has been carried out in northern India. So empirical equations, empirical formulas, we can use for finding runoff. We can use some empirical formulas. Okay, for determination of runoff, we can use some empirical formulas, sir, such as we have Binet's formula, okay, we have Barlow, we have Khosla. Many scientists have worked and given different formulas. Obviously these formulas are not so important, okay, but yes, empirical formulas are there. Just for the sake of knowing, I am telling you this thing so that some points will remain in your mind. We can use certain kind of tables and curves. I have told you about Horton curve. Okay, in that Horton curve, sir, if I want to find runoff, sir, what I have to do? I have to simply draw the infiltration curve and find the total infiltration value, and from your total rainfall, I will subtract this infiltration and get the excess rainfall and get this runoff. Okay, this runoff you have already computed. How? Sir, from total precipitation, I will subtract infiltration in order to get the runoff. So this is a kind of curve. This Robert Horton curves will give me the runoff part. Okay, and this procedure we have already understood. Okay, so from different tables are there, different curves are there, different numerical formulas are there. Okay, many methods are there with the help of which I can find runoff. Okay, many different methods are there. Then we have runoff coefficient method. Which we will discuss in the flood chapter. Runoff coefficient method is there. Obviously, what we have to do in runoff coefficient method? Okay, you all know that runoff is C times rainfall. Okay, C is runoff coefficient. Multiply runoff coefficient with C and get the value of runoff. I hope this thing is clear. Then we have infiltration curves. This we have already discussed right now. Okay, we can find runoff value from infiltration curves also. Okay, I told you about infiltration curve just now. Then we have water budget equation. Okay, water budget equation is there. And at last we have runoff rainfall correlationship. Runoff correlationship. See, this correlation thing is you will study in probability in mathematics. In probability, you will study this runoff rainfall correlationship. Okay, in which if you want to find runoff, you can put the value of P here in this equation. If you want to find runoff, simply put the value of precipitation. Find this constant A and B from the data which you have. Okay, from the data which you have, from there you can find the value of A and B and simply put A and B here, then put the value of precipitation and simply find runoff. Okay, not so important, but yes, once this question has been asked in mains, not so important. Okay, so that's why we are not discussing, but yes, I have told you all the methods, how with the help of which how you can find the runoff or how you can compute runoff. Okay, tell me, is this thing clear? So these are different kind of methods with the help of which you will find runoff volume. Now we'll discuss, which is our last topic for today. We'll discuss what flow duration curve is. Okay, at last we have to discuss about flow duration curve. Now what is flow duration curve exactly? What is flow duration curve exactly? I will tell you, I will let you know. Okay, so now we'll discuss about flow duration curve. Now we'll discuss about flow duration curve. Okay, so flow duration curve, obviously you are as the name suggests, that it is a discharge, it is a flow means discharge, duration means how much percentage of times that flow has been equal or exceeded. Okay, let us try to understand very clearly. Listen. Okay, so let us say we will have a graph. Okay, we will have a graph of flow versus duration. Okay, sir, what is the exact meaning? What is the exact meaning of flow versus duration? See, on the y-axis, we will have discharge, and on the x-axis we will have, percentage of times. We will have percentage of times, or simply the probability, percentage of times that flow, percentage of times that flow has, equaled, percentage of times that flow has equaled or exceeded. Okay, now what is the meaning exactly? You need to understand one thing from here. See, I have already told you. Let us imagine we have a huge river here. Let us say we have a huge river here. Now, sir, lower the discharge. Let us say we have some less discharge in your river. Sir, that less discharge will always be present in that river. Okay, let us take an example. Let us say this river is having 10 meter cube per second discharge. So this 10 meter cube per second discharge will always be present. So its probability of occurrence, of this discharge greater than 10 meter cube per second or equal to, what I have written here, that 10 meter cube, flow means discharge. So 10 meter cube per second discharge has equaled or exceeded. Okay, in this river, how many times 10 meter cube per second discharge has equaled or exceeded? Sir, in this river, how many times 10 meter cube per second discharge has equaled or exceeded? That is 100%. That means throughout the year, every time when you come here, sir, whenever you come here and visit this river, you will see that 10 meter cube per second discharge, at least 10 meter cube per second discharge is there, at least. So this is having 100% probability. Now let us say increase the discharge. Let us say we are talking of 50 meter cube per second. So sir, what is the probability that my river is having 50 meter cube per second discharge? Sir, what is the probability my river is having 50 meter cube per second discharge equal to this or greater than this? Equal to this or greater than this. So let us say the discharge will be, this discharge is found 75% of the times. Okay, the value 75% means out of every 4 times you will get only 3 times. This discharge will be witnessed only 3 times. Out of 4, 3 times. 75% means this. Yes or no? Okay, so try to understand. So 75% means, probability is now less as comes. Now more the discharge, let us say we have a very huge discharge. Let us say 500 meter cube. Okay, so let us say in this river flood has occurred. Okay, this river has almost overtopped. Huge amount of water is flowing in this river. So what is the probability, what is the percentage of times that this discharge will be equaled or exceeded? Let us say it is having only 1% chance. 1% out of 100 times, only 1 times you will see that this kind of discharge is there in this river. Okay, that it has been overtopped. That means out of 100% times you will have only 1% times, that is probability is only 1 by 100. Its occurrence of the occurrence of this kind of flow or greater than this. Okay, the probability of occurrence of this kind of flow getting equaled or exceeded means more than this is only 1%. So you can see from here that higher the discharge, lower is its probability. Yes or no? Higher the discharge, the lower is the probability. Yes sir, this is clear. Higher the discharge, lower is the probability, which means if I am going to plot discharge and see, this is nothing but probability. So if I am going to draw some values here, if I am going to draw this graph, this will be what? See, higher discharge will have lower probability. Okay, lower the discharge. See, lower the discharge, if we have lower discharge, okay, probability will be more. So this graph will be somewhat like this. You will join this and you will get a graph like this. Okay, obviously you can see when probability is more. Okay, you can see here when probability is more, sir. sir, when probability is more, let us say 90% like that, then I have less discharge. Okay, let us take an example. 10 meter cube per second will occur for almost 90% of the times. This 10 meter cube per second or greater than this discharge will be there for 90% of the times. But let us say we have a very high discharge, let us say 500 meter cube like that. So this huge kind of discharge will be there for very, very less time. Let us say for 1% only. So higher discharge is having lesser probability. So I hope this is clear. Okay, I hope this thing is also clear. So this is your flow duration curve. So have you understood this thing? So flow duration curve means it is a plot of, let me write, a flow duration curve of a stream is a flow duration curve of a stream is a plot of a flow duration curve of a stream is a plot of discharge against. So on y-axis we have discharge. Okay, plot of discharge against probability, against its occurrence probability. Okay, for what probability it will occur, against the percentage of times, it is written here, against the percentage of time, the flow was, against the percent of times that flow was equaled or exceeded. Okay, so I hope this thing is clear. That flow percentage of time the flow was equaled or exceeded. So this is your basically flow frequency curve, flow probability curve. This is also known as discharge frequency curve. Discharge means flow and probability is frequency. Discharge frequency curve. Percentage will give you frequency only. Percentage of probability gives you frequency only. But one thing which you can understand from here is that discharge which occurs here is inversely related to probability. Higher the discharge, lesser is its probability. Okay, so let us take an example also, so that whenever you revise your notes you are able to understand. Let us say we have 75% dependable flow. So what is the meaning of 75% dependable flow? Okay, what is the meaning of 75% dependable flow? So the meaning of 75% dependable flow is that this kind of discharge, the discharge, let us say 250 meter cube per second. So 250 meter cube per second will occur, or greater than that, greater than 250 meter cube per second will be there for 75% of the times. Okay, so the discharge 250 meter cube per second, okay, will occur with probability greater than equal to 75%, or its frequency will be 1 by p. Okay, so that is the meaning of 75% here. Okay, 100% means that 100% discharge, 100% dependable flow means we have a certain value of discharge which will be there for 100% of the times. Okay, that will be there for 100% of the time. So this is your what? This is your flow duration curve. See why this is important, because let us say we have to let us say this is your river. Okay, try to understand why we are in need of flow duration curve. Listen very carefully. So let us say you have a river. Okay, from that river you have to supply water to the city. Okay, from that river you have to supply water to the city. So you will obviously design your water supply. Obviously you will design your water supply for that kind of discharge. Okay, for that kind of discharge which is available for most of the times of your year. Okay, let us say we have a discharge of 50 meter cube per second almost 90% of the times, which means 90% dependable flow is 50 meter cube per second. 90% dependable flow means 90% of in 90% times in your entire year, in 90% times I will witness 50 meter cube per second discharge is there or greater than this. Okay, equal to this or greater than this discharge is there 90% of the times. So I will discharge my water supply facility for 50 meter cube per second. Okay, so and if you want that, if you want your if you want to make sure, if you want to make sure that your water supply has minimum let us say certain amount of discharge throughout the year, so I want to find in that case 100% available flow. In that case I want to find 100% available flow, because let us say 100% available flow here is 20 meter cube per second. Okay, because this 20 meter cube per second or more than this discharge will be there for 100% of the times throughout the year. That means your 100% available flow for your water supply scheme will be 20. So this discharge will be there for 100% of times. 50 meter cube per second discharge or greater than this will be there for 90% of the times, like this. So we are, when we have to design for any kind of supply, then I will make sure we are taking 100% available flow or 95% available flow, so that at least this much amount of discharge is ensured throughout the year. At least minimum discharge is ensured throughout the year, so that my water supply facility is getting some amount of water. For that purposes, we require flow duration curve. I hope this is very, very clear to you. Okay. So this is the end. I hope everything is clear to you. Okay, so this is your flow duration curve. Okay, now in tomorrow's class, basically we'll discuss your stream flow measurement, how to do stream flow measurement, because after runoff, I have told you today that after precipitation, wait a second, let me delete all these slides which we have already covered yesterday. Okay, yesterday's slides, let me delete. Yes, so I told you today that after precipitation, yes, after precipitation, all the losses takes place, all the abstractions. See, this is your chapter 2, this is your chapter 3. In this, evaporation, transpiration, evapotranspiration, infiltration, and interception, depression, all these things we have already studied. After this, runoff takes place. Runoff is also now finished. Runoff is also covered. In today's class, we have discussed what basically runoff is. Some part is quick, some part is slow. That we have also discussed. Now, whatever runoff is there, that will automatically convert into stream flow. So tomorrow we are going to measure stream flow. Tomorrow's chapter is stream flow measurement. And what things you will measure in stream flow? Sir, obviously we will measure 3 things. Okay, sir, we will measure the depth of water in the stream. We will measure the velocity, how fast your water is. Okay, we will measure the velocity of water, and at last we will measure the amount of discharge. What is the flow there? Okay, these 3 things we'll measure tomorrow. So in tomorrow's class, we will discuss your stream flow. Okay, so I hope this is clear. Sushil is asking which one is best for me, Parakram batch D or Parakram 2.0. See, you can take any of the batches. Okay, you can take the 2.0 thing. Okay, because in the latest 2.0 thing, all the things will be covered. So you can take the latest one. Okay, dear. Parakram, see, whatever batch is starting from latest time, that you can take. Like in tomorrow, see, today is 16th March. From 20th March, one batch is going to start, that you can take. Okay, whatever batch is starting from the latest time duration, you can take that one. I hope this thing is clear. But if you want to see the recorded videos, then you can take some earlier batches, because in that some lectures have already run, and those recorded videos you will get there. But if you want to catch up live, you can join from the latest date. Okay, in which when the subjects will be covered, those will automatically get recorded in the form of video, in the form of recorded videos in your app itself. Okay, so this is it for today. We'll catch up tomorrow with stream flow. Okay, so thank you everyone. We'll catch up tomorrow. Good night, take care, stay blessed, and keep revising and practicing questions.